Alright, I got this model called Old Sim with Membrane 8. And you can see that it's 1/8 of this square domain. And I actually built it in Maxwell. It has all these modeling tools, so you can see create, subtract, unite, and fill it was important for making the edges round so that things didn't blow up when I solve for the electric field. But let's see if we can hide certain things and just show parts of it. So this is the membrane, and you can see if I do this that it's 1/8 of a square with a hole punched in it, and then it's got a certain thickness. And over here I've got the, if I click on the solid it'll show up, I've got the material properties. If I click on the water, and one thing at a time here, that's everything going through the pore, and then the rest of the simulation domain. And then if I click on this tube, this is the metal part. Okay, so a lot of steps, probably the most steps to make this one. So I'll put this model up to mess around with. And I can make everything visible if I want, but it actually works better to make things invisible and then solve for the electric fields. Now this model right here has the parameters set up so that you can, and let me see, if I make everything show, you can see it all at once. See how it goes together. View, show in active view. Okay, so now when I don't have it selected, you're still able to see the stuff. Okay, and these buttons are up here, pretty handy. You'll get the idea. There are boundaries that I put on this thing, and wow, over here in this window, Project Manager, it gets kind of busy. You can show where the boundaries are, and these are places where I set mirrored conditions so that on this side, on the kind of the front face, let me see if I can flip it around. So I'm looking down on it. This lower part of the triangle is going to be mirror imaged with another triangle, and on forever. Same for the vertical flat side of the triangle. It's got a boundary condition. You can see this kind of plaid-like pattern on it. It's going to have a mirror image with something that's on the other side. So we're creating an infinite array of pores by putting this symmetric boundary on all the vertical faces, and the ones that aren't the top and bottom. And the top and bottom are going to have a voltage on them. So they're called excitations. And now we're seeing, when I click on floating, oh, and the middle, the metal that isn't connected to anything. Okay, you've got your top electrode and your bottom electrode, and the metal here has to come to whatever potential makes all the equations work out. It makes it have, it's going to stay charge neutral. So we call it floating. And top voltage, and we can look at what that is. But it's the condition that you're putting on the wire that you're putting in. And then bottom voltage is the indium tin oxide, or vice versa. You can flip them around. They're just these flat areas. So we've covered the whole surface, and now we can solve for the voltage in the water and also in the membrane. Inside the tube and flange, the metal, it's all going to be a constant voltage. It's that metal doesn't have an electric field inside it. It's just whatever voltage it comes to.